My name is Benjamin Wachter, and this is Lab 3 for Physics 2212. In this experiment, I used a simple bar magnet to find the magnitude of the electric field in various locations, and I compared these values to theoretical values given for the equation for B, the magnetic field, in terms of mu, the dipole moment, and r, the relative position vector of the observation location. This lab relies on fundamental principles of magnetism, as well as a general understanding of magnetic dipoles and their resulting magnetic fields. This lab demonstrates that the magnetic fields are functions of the relative position of the observation location and the magnetic dipole moment. Specifically, it was determined that the magnetic field is a function of 1 over the relative position cubed and the dipole moment. The following data and observations were collected. N from the Excel spreadsheet was found to be negative 2.5216. The experimental value for the magnitude of the magnetic field was found to be 114.8 microteslas, whereas the value for the magnetic field was found from the GlowScript model to be 0.1169 microteslas. This is several degrees of magnitude off from the experimental value. It was observed that a near zero magnetic field was exhibited when far from the magnet, and that as the magnet was brought closer to the observation location, the magnetic field increased. Here are the significant portions of the GlowScript model that I wrote in GlowScript. The first being a function for the magnetic field B of an observation location given the mu, the magnetic dipole moment, and r, the relative position vector. The second being codes for arrows that represent magnetic fields at various locations around the magnetic dipole, including locations that are perpendicular and parallel to the magnetic dipole moment, as well as one that is in the same plane but at a 45-degree angle to the magnetic dipole moment. Here is the result of the GlowScript code and the model. The teal arrows represent observation locations that are perpendicular to the magnetic dipole moment. The orange arrows represent observation locations that are parallel to the magnetic dipole moment. The purple arrow represents the observation location that is in the same plane as the magnet, however it is at a 45-degree angle. In the text below, you can see values in vector form for vectors of the magnetic fields at all of these different locations. Also included is the distance d that the purple arrow is from the magnet, as well as the magnitude of B in microteslas. If I had laid the meter stick at some arbitrary point, then my results would change drastically, depending on the orientation with respect to the magnetic moment of the Earth. Because depending on how it is oriented, the magnetic field of the Earth would either add or subtract from the x component of my magnetic field, and would make calculations of the system unreliable. If I had placed two identical magnets side by side with their poles touching, it would be as if I used a magnet that was twice the length of the magnet I had actually used.